Okay, what we're going to do is a real quick lesson here on rational exponents. This isn't going to be the most in-depth lesson on rational exponents, just a real quick one, maybe just kind of get you started, give you a general idea of how to do these kind of questions and what this even means. So, first of all, the word exponent is sometimes referred to as a power. You guys have probably seen this before. For example, 3 squared. 3 is what's called the base, and this little 2 up here, that's called the exponent, or the power. And what an exponent means is you take the base and you multiply it by itself this many times. So 3 to the power of 2 means 2 3's multiplied. Or 5 to the power of 3 means 3 5's multiplied. It would be 125. That's what an exponent is. Rational means it has something with a numerator and a denominator. So what we're talking about here are exponents, these things, that the exponent itself has a numerator and a denominator. Or you could say exponents that are fractions. Okay? I think you guys know what this means. Let's talk about what the heck does this mean. So here we have a exponent, right? This is the base. 2/3 is the exponent. And the exponent itself is a fraction. This is called a rational exponent, or a fractional exponent. Now, the first thing that we should understand is you have to be able to convert a rational exponent into a radical, or radical form. So we could call this over here exponential form, and we need to be able to convert this to radical form. Okay, what this means is this bottom number here is called the index. Okay, now up until now you may have seen radicals, which you might have called square roots. For example, the square root of 9 is 3. Meaning, what times itself makes 9? Well, 3 does. 3 times 3 makes 9. This you may have been calling a square root, which is correct, because you can't see it, and it's invisible. There's a little 2 in there. And the reason why this is called a square root is because you're asking yourself, what times itself, like 2 times, makes 9? Well, 2 3's gets to leave as 1 3. That's why it's called a square root. Now, these radicals, which look like these fancy dividing symbols, aren't always square roots. Maybe the first time you've ever realized that. You could have a cubed root, or a fourth root, or any root we'll call an nth root, or the index. Okay? That's what the bottom number of the fraction is when it's a rational exponent. The denominator is the index. So just to start, this question here means the third root of the base to the power of this, the numerator, squared. Okay? So the first thing you need to be able to sort of get good at, just a basic skill, is how to convert something from exponential form into radical form. So do a couple practice questions like this. So what I'm expecting is for you to, I'm going to give you a question that looks like this. I want you to rewrite it so it looks like this. Okay, 5 to the 2 sevenths. Okay, and 6 to the 4 thirds. X to the 1/4. And 9 to the 1/2. Okay, so just getting started here, all this is just convert these from exponential form into radical form. Those numbers are the index. So you could start by just doing this. That one's a 7 in there, that one's a 3, that one's a 4, this one's a 2. Okay? Any questions about that? I don't see any hands. Okay. Then you write the base inside. This would be a 5, this would be a 6, this would be an x, and this would be a 9. And then the numerator, this is like the power, okay? You know, for example, just off to the side here, 4 squared, you could think of that as a rational exponent, 4 to the power of 2 over 1, right? So this is what you multiply the base by. How many times you multiply the base by itself, sorry. So 2 is out there. I always make those too long, and I have to, let's see, go back and erase this. Looks funny. Okay, like that, like that, like that, and like that. Okay, hopefully you got these right. How many people had all those red answers? Yes. Okay. Any questions about converting from exponential form into radical form? Okay, let's try a couple going the opposite direction. I'm going to write these in radical form. You change them to, very good, exponential form. Ready? Here we go. This, by the way, would be the same as writing it like this. Okay. Okay, so this is radical form with the index into exponential form. Just step by step here. So this is the index. Those are the denominators. So what we got here is 6 to the power of, very good, 8/5. Okay, now you can simplify that 6 to the power of 8/5, but we're not going to get into that just quite yet. I just want to see if you can master this like real narrow skill here. So 6 to the power of 8/5. Okay, this one here, x to the power of, good, 11/3. And the last one, if you wrote this is wrong. And I know some of you wrote that, right? Yep. Okay. Now, the reason why, don't feel bad, this is a common mistake. The reason why this is wrong is because this 3, you have to think about, this 3 right here is an exponent. What's the base, or what's the 3 attached to? Is it attached to the x, or the 5, or both? It's not attached to both unless there were parentheses here. Then it would be 5 to the 3rd and x to the 3rd. Since there's no parentheses, this 3 is just attached to the x. This is x to the 3rd power. This 5 is a different base with its own exponent. And since you can't see the exponent, it's a 1. So this here, not correct. And if this was a multiple choice test, that probably would be one of the choices. The correct answer, hopefully you can see it, is 5 to the 1/4, x to the 3/4. Okay? Try one more like that. Number 8. Let's try the 5th root of 9 x to the 11th. Good. 9 to the 1/5, x to the 11/5. Okay? So that's a basic idea of converting from rational exponent form into radical form and back and forth. Okay, so again, this is, call this exponential form because you're written with exponents. This here, you call this radical form. Okay, now once you're good at converting those, you should work on how to simplify. So let me give you a question here. 8 to the power of 3/2. So first of all, you don't have to do it this way, but this may help explain it. Let's just convert that. It's in exponential form right now. Let's convert it to radical form. 2 is the index. 8 to the third power. Okay? And we have to simplify this. We've simplified square roots before. Just kind of step back for a second. You know, I've given you questions like the square root of 12, and you have to simplify this. Now, this is a square root because there's no number in here. If they were going to write a number in here, they'd write a 2. But if they don't write a 2, then there's no number. So this is called a square root. And when we did this, remember we factored it like this. 3 is prime, 2 and 2 are prime. We figured out the square root of 12 is 2 times 2 times 3. And then we took out these two 2's. 2 times 2 is 4, and the square root of 4 is 2. So these two 2's left is 1 2, and what was left inside is the 3. The reason why we were looking for double 2's, or two 2's, or if like this was cards, 2 of a kind, the reason why we want 2 is because we're dealing with a square root. So if I were to change this into a cubed root, then we couldn't take anything out, because now you're looking for 3 of a kind. I only have two 2's and one 3, so there's nothing that would come out of a cubed root. You just have to leave this as the cubed root of 12. It's as simplified as possible. Now, back to this question over here. 8 to the power of 3 over 2, written in radical form here in the red. You could imagine that this is the same as this, the square root of 8 times 8 times 8, right? So here's a really nice way to think about these. This bottom number, the index, right? That's what you need. It's like if this is a game, that's the rule. You need that in order to remove something from inside the radical. Okay? If you have that, like there's maybe some guy and you show him, hey, he's saying, I need to see 2. If you show him 2 of a kind, he'll let you take those out of the radical. So the bottom number is what you need for this game. The top number is what you have. So in this case, I have 3 8s and I need 2 8s. So do I have enough to take one out? And the answer is yes. If you need 2 and you have 3, you know, that think of that looks like this. Well, I got 2 8s right here. So you show the 2 8s and they're like, yeah, that's 2 8s. Good. Those 2 8s get to leave as 1 8. And what's left inside is this 8. So these guys leave, this guy stays. Because 2 8s get to leave, the rule is 2, 1 8 has to stay in. Now, you definitely don't have 2 more 8s inside of here, right? There's only 1 8. So you can't remove another 8, but you may have more than one factor inside the 8. So now you want to factor the 8. We know we don't have 2 8s to remove, but we might have 2 of something else to remove. So if you factor the 8, you get this, 3 2's. So what we have then is 8, that's this 8, times the square root of 2 times 2 times 2. Now again, the index is 2, that's the rule. They're saying, show me 2 of a kind and I'll let you leave. Well, here's 2 2's. Pass, you get to leave. So now I have outside another 2. I have an 8 and a 2 outside, and I have, the square root of this 2 stays in. He doesn't have a pair. I multiply these, and I write 16 square root 2. That's it. Now we know there isn't another pair in here. We need a 2. We need 2 2's. We only have 1, so that's as simplified as possible. Does anybody have any questions yet? Let me just back this up here. You can kind of see the big picture. I don't know if that's too small, maybe. Oh yeah, yeah. Good. Okay, good question. So Nancy says, we got down here. How come I didn't write the 2 in here? Shouldn't there be a 2 right here? Did I mess this up? Did I forget to do that? And the answer, although I do mess up, that this time I actually didn't. I meant to leave that blank. If you just leave this blank, then you're telling everyone that's a 2. Okay, so if you write nothing in there, then it's an imaginary 2. It's the same thing as, I typically don't write 1x. I just write x. And if I just write x, we all know by now that means 1x. I don't have to write the 1. It's the same idea. If I don't write a 2 in here, then it's automatic. This is a square root. If you want it to be anything besides a square root, then you have to write the number in there. Now, you could write a 2, but I don't know, looks silly. Okay, 16 square root 2. So just quick review. We have this rational exponent. We need to simplify this. We have basically the top number is what you have, the bottom number is what you need. We have 3/8, we need 2. Well, we can remove 1. So we remove this 1/8, and then we have 1/8 left inside. There isn't 2 more 8s to remove, but an 8 contains 3 2's when it's factored. So although we can't remove another 8, we can remove 2 2's as 1 2. So on the outside we have this 8, and this 2 makes 16. This 2 here stays inside, so we have 16 on the outside, square root of 2. And again, we don't have to write the 2, we just leave it like that. Okay, that's simplifying a rational exponent. Try this again. Ready? Everyone ready? Okay. 54 to the 5/3 power. Simplify that. Okay, if it helps, rewrite it in radical form. Radical form looks like this. Meaning we have 5 54s. This, right? 1, 2, 3, 4, 5. That yellow is just a short, fast way of writing this. So we've got 5 54s. This is what we have. This is what we need. We got 5 54s. We need 3 for this game. It's like a guy there saying, "Hey, you show me 3 of a kind, I'll let you out." Well, we do have 3 54s, right? In fact, we have 5 of them. These 3 are going to get to leave. So on the outside, I have a 54, and on the inside, I have these 2 54s. So you could write 54 squared in there if you want to. Now, I forgot to write something on this, and I did that on purpose, Nancy. If I don't write anything here, then this changes to a 2, and I need this to be a 3. Good. So you have to write that in. All right, so we started out with 5 54s. We needed 3, so these 3 did leave and became this, and these 2 had to stay in, and I just wrote that as 54 squared. You could multiply these together, but I don't think you'd want to do that at this point because you're not done simplifying. Now, it's just like the last one. We know there isn't 3 54s in here. There's only 2, but there may be 3 of something else if we factor the 54. So just do this. 54, that's this one, times the 3rd root of 54 times 54. That's 54 squared factored, broken into 2 54s. And then just factor these 2 side by side like this. 54 would be like a 9 and a 6. So we got 3, 3, 3, 2, 3, 3, 3, 2. What we've figured out here is 54 times 54 is the same as 1, 2 2's and 1, 2, 3, 4, 5, 6 3's. Okay, so we have 54 on the outside, cubed root of all this. Now again, the reason why I factored this is because we're looking for 3 of a kind. Do we see 3 of a kind in there? Well, I only see 2 2's, so the 2's, sorry, not enough, you have to stay in. Here's 3 3's, and here's 3 more 3's. So 2 groups get to leave. You guys get to leave as a 3, and you guys get to leave as a 3. So on the outside, I've got 3 numbers now, 54 and 2 3's. 54 times 3 times 3 times the cubed root of these 2 2's stay inside. So this is this, right? And this would be like this one. This would be this one. And then the 54 is the 54 that was already out there. So we removed all the triples, or 3 of a kind. Now I just multiply these on the outside. 54, probably do 54 times 9, like this. 48, right? 45, yeah. 486 cubed root of 4. That's the simplified version of this. So this would be considered the final simplified answer. Now just as a bonus, anybody think they could change this answer into exponential form? Delvin? Good. Okay. 486, that's like to the first power, times 4 to the, good, 1/3 power. That's another way to write this answer. This is like to the first power, right? Index. Okay. If this were a multiple choice test, I guess you could, either of these might be the choices. You wouldn't see both of these. They both mean the same thing, but either one of these could be the correct answer. Okay, let's do one more here. About this one. Okay, so again, exponent, it's a fraction. We call this a rational exponent, right? If you want to, you could rewrite this in exponential form, or I'm sorry, in radical form. This would be the 3rd root of negative 64 to the 7th power. We have 7 negative 64s in there. We need 3. So we have, how many groups of 3 are in 7? Good, 2. Okay, so we got 2 negative 64s on the outside, and the cubed root of a leftover 64. That's what we have right now. This is what we need. This is what we have. Okay, now the negative 64, let's break that down. I'm going to do this first. 8 and 8. 8s are 4 and 2, so it's 3 2s. So what I got is 6 2s and this negative 1. Let's take, we're looking for 3 of a kind. There's 3 2s, there's 3 more 2s. Right? Okay, so what we have on the outside is negative 64 squared, 2 squared. 1, 2, 2 2s. There's 2 of those multiplied together. Cubed root of negative 1 inside. Right? Now, think about it like this. This question, this part of this is saying, what multiplies itself 3 times to make negative 1? Well, you think, well, that's an imaginary number. You know, you can never have a negative inside that radical, and that's not true. It's not that you can never have a negative inside of a radical. It's that you can never have a negative inside of a square root. And we'll get into this more in depth, but basically, this is imaginary here only if you have a negative in here and this number is even. In our case, this number is odd. There's actually a real number solution to this. We're asking ourselves, what multiplies it by itself 3 times to make negative 1? And that's negative 1. Negative 1 times negative 1 times negative 1. There's 3 of them. That makes 1. Times that is negative 1. So the cubed root of negative 1 is negative 1. So what we have on the outside is a negative 1, a negative 64 squared, and a 2 squared. And there's nothing left inside, so you don't even have to write this. There's nothing in there. That's it. You may want to multiply these together. Can you tell whether the answer is going to be negative or positive just before you multiply them? That's right. Good, negative. This here, negative 64 squared is positive, this is positive, and this is negative. Multiply those together, and we get a negative answer. Now, I don't have a calculator. Well, I guess you could do 64 times 64 like this. Or, let me just type this in. Probably shouldn't be doing this. Whatever. Okay, this is 4096 times 4 times negative 1. Oops. Which is negative 16,384. That's the simplified version of the question. This turned into this. Okay, this is simplifying rational expressions. You can think of a rule, I guess, if you wanted to write one. X to the a over b is the same as the b root of x to the a power. That's how you change from exponential form to radical form. This top number is what you have. This bottom number is what you need. Okay, almost finished. The last thing I'm going to show you is how to solve equations that involve rational exponents. So, you may see a question like this. How about 2x? Let me think of a good one here. To the 3/2 power equals 48. Okay, so this question is asking us to solve, which is telling us to figure out what could x be that would make this equation true. What would I put in this box that'll make 48 over here? So if you get an equation like this, you have to solve this, and it has a rational exponent. The first thing you want to do is, wherever you see the x, it's got this exponent on it, try to get this part by itself. Just isolate the yellow. Which means somehow we have to get rid of this 2 here. Since this is 2 times x to the 3/2, we don't have to worry about the 3/2 power right now when we're dealing with the 2, because the 2 has its own exponent, a 1. This 3/2 would be attached to the 2 if there were parentheses. Since there's not, this is just 2 to the 1st power. So if we want to get rid of this 2, we'll just divide by 2 on both sides. It's going to leave us with this. Okay, now the next thing we got to do is now we just got to get this x by itself, so somehow we got to get rid of the 3/2, because our goal is to eventually get to this. Now, you can use the power property of laws of exponents. It says this: x to the a to the b power equals x to the a times b. We want this to say x to the 1st power. So think about it as, what do I have to multiply 3/2 by? That's like the a. This a times what b is going to, when I multiply them, is going to make 1. And the answer is the reciprocal of 3/2. If I multiply this by 2/3, or take this, raise this to the power of 2/3, then I'd be multiplying these two using this rule. 3/2 times 2/3 is 6 over 6, which is good 1. So this is the inverse of this, cancels it out. We just have x to the 1st power, right? Nancy, is it all right if I don't write this 1 right here? Is it fine? Okay. And now if it's solving equations, properties of equality, if I'm going to raise the left side to the 2/3 power, I got to raise the right side to the 2/3 power. So I get 24 to the 2/3. So now technically, that is the answer. We've solved this for x. The x is by itself. This is all solving. Solving is done. But what we still need to do is simplify this, and we went over that just a second ago. We need 3. We have 2. We have 2 24s, and we need 3. We don't have enough 24s to take any out, but we might, within the 24, there might be a 3 of a kind. So what we have right now is this: the cube root of 24 times 24. 224 squared, 2 24s. Now, a 24 is a 6 and a 4, or an 8 and a 3, or a 12 and a 2, however you want to start it. But it's going to turn out to be this. cubed root of, let's see, we got 1, 2, 3, 4, 5, 6 2's. Once you do this enough, you could just write 2 to the 6th. I think it's important, though, to kind of write it out when you first start doing this. So we got 6 2's and 2 3's. And the rule of this game is 3. We need 3 of a kind. Can we show 3 of a kind anywhere? Yeah, there's 3. You guys get to leave as a 2. Oh, there's another 3. You guys get to leave as another 2. You guys have 2 of a kind. That would be good if this was a square root. Unfortunately, it's a cubed root. Sorry, 3's. There's only 2. You have to stay in. So the simplified version of this is 2 outside, cubed root of 3 times 3, 9 inside, or 4 cubed root of 9. That's the simplified version of the answer. If you wanted to write that in exponential form, it'd be 4 times 9 to the good 1/3. Okay? Let's do one more, and I think that'll wrap this up. Again, you can get way more in depth into this. This is just kind of quick, fast lesson, rational exponents. Okay, one more. Solve for x. Ready? Everyone ready? Everybody's ready. Okay. 2x to the 3/5 plus 4 equals 196. Okay, solve this equation for x. If you're just totally stuck right now, you don't even know where to do, remember the first thing is we want to try to isolate this first. Once we've isolated that, then we can get rid of the exponent. Which means the things we don't like in this question are this 4 and this 2. We need to knock those guys out. Do that doing inverse operations, properties of equality on the equations. The opposite, or the inverse of adding 4 is subtracting 4. I'll do that to both sides. That's going to leave me with this. Okay, so here's my yellow thing. Remember, the goal here is to first try to get this part by itself. I got rid of this 4, so my job here sort of is partway done. Now I have to get rid of this blue 2. And to do that, I will divide by 2. Half of 192, anybody? Good, 96. Okay, so first part of my little mission here is mission accomplished. Got the yellow part by itself. I got rid of these blue things. Now that this is by itself, now you want to try to get this by itself. So now focus on this guy. How do I get rid of the power of 3/5? Again, you raise it to the power of its reciprocal, 5/3. Gives you x equals 96 to the 5/3 power. Okay, again, this is technically the solution. We solved it. Now we need to simplify it. We need 3. We have 5 96's. Do we have enough to remove any 96's? Yeah. We only need 3. We have 5. So we have a 96 on the outside. And what's on the inside is cubed root of 2 more 96's. We had 5. 3 of them are here. The other 2 are staying inside. This 3 is this. Now we know we can't take out any more 96's. We need 3. We have 2. So we're going to factor this apart. Maybe there's something else in here. Now we're looking for 3 of a kind. Okay, 96 is 2 times 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3, right? So I know 96 is 1, 2, 3, 4, 5 2's and 1 3. 5 2's and 1 3. And that means this other 96 is also going to be 5 2's and 1 3, right? So what I have is x equals 96 cubed root of how many 2's? 10, good, 10 2's. See, 5 from this one, 5 from this one. And how many 3's? Good, 2 3s. One 3 over here, this one 3 over here. I'm looking for 3 of a kind. Well, I got 10 2s. That's more than enough, right? Okay, so I got 96 outside. 1 2, that'll drop me down to 7 2s on the outside. I can go again, that'll drop me down to 4 2s. And go again, that'll drop me down to 1 2. So we're looking for groups of 3, we have 10. That's 3 groups of 3, 1 2 3, and then 1 2 left over. And 3 2s, or 2 3s, sorry, not enough. So x equals 96 times these 3 make 8. Cubed root of 9 times 2 is 18. Now you just have to multiply 96 times 8. I'll let you guys do that this time. 96 times 8, anybody? Good. 768 cubed root of 18. Solving rational equations, simplifying the answer. You could also write this as 78 times 18 to the 1/3 power.